For the number of gold coins in a 50 square meters area, where D is going to follow a Poisson distribution of 0.8 multiplied by 50, by applying the scaling property of Poisson distribution, where 1 square meters is 0.8, so 50 square meters is 0.8 multiplied by 50. This will give me D to be a Poisson distribution of 40. We are going to do the same thing for E, which is the number of pottery shards in 50 square meters, because it is given to me that the mean for 1 square meter is 3, so this is 3 multiplied by 50. Okay, so E is going to follow a Poisson distribution of 150. I'm supposed to use an approximation to calculate the probability that the total number of gold coins and pottery shards that are found in a 50 square meters area is going to be at least 200. There are two ways that I can go about continuing with this question. The first way is to immediately find D plus E, because applying the additive property of Poisson distribution, D plus E will just follow a Poisson distribution of 40 plus 150. I get the new Poisson distribution, I can carry out an approximation. In fact, it is going to be approximated very nicely to a normal distribution. There's another way that I can go about doing this, which is to approximate them to normal distribution first before I carry out a linear combination. Okay, I'm going to go for this. Actually, my primary motivation, right, it is because I can actually use that for the next part of the question, the last part of the question. Okay, I'm going to explain this again, in part 6, the last part of the question. So for now, let's just go ahead, and try to approximate this to the normal distribution individually, because I'm going to do a test first in order for me to carry out that approximation. Lambda, which is 40, this is bigger than 10. That is why D can follow a normal distribution of 40, 40. And this is an approximation. The same for E. For this, the mean is 150. This is bigger than 10. That is why E over here can also be approximated to a normal distribution of 150 and 150. And this is also an approximation. So I'm going to write this as approximately. Okay, so now I want to find another distribution that can take into account of D plus E. Okay, since there are normal distributions over here, I'm going to find the new expectation, which is expectation of D plus E. This is the expectation of D plus the expectation of E. So this is going to be equal to 40 plus 150. Okay, this is giving me a 190, and I want to find what is the variance of D plus E. This is the variance of D plus the variance of E. And this is also going to be 40 plus 150, which is 190. That is why D plus E will follow a normal distribution of 190 and 190 approximately. What the question wants is for us to find the probability that this total is at least 200. But what we know is that D and D, which started off as discrete random variable, we are trying to approximate the distribution into a continuous random variable. That is why we need to apply the continuity correction. So applying it here, D plus E will be bigger than 199.5. This is carrying out a continuity correction and pressing this into my graphing calculator by making use of the normal distribution. This is equal to 0.245.